In the previous video, I gave you a word problem or a practical problem that needed to be modeled as a normal distribution so that we could work out, in this instance, the probability of being able to keep a fish that we have caught. And we worked out that it was 92.29% chance of keeping that fish based upon the information. I'm going to add a second part to it now to show that you can add extra skills or different skills to solve different parts of the same problem. So I've got here, it's a good day for fishing and you managed to catch 15 fish. What's the probability that you only have to throw back at most one fish? Now, this particular problem, believe it or not, is a binomial distribution problem. And you are going to use the binomial distribution skills to solve this problem. Why is it a binomial distribution? Well, the properties of a binomial distribution are as follows. Is the probability binary? In other words, it is just a simple success fail. And the answer is yes, it is. You either catch and keep a fish or you catch and throw it back. That's all we're looking for. Secondly, is there a discrete number of trials? Yes, there are. It's discrete, countable, 1, 2, 3, 4, 5, etc. And there are 15 fish caught, which means 15 trials. So we have all the parts that we need to model this as a binomial distribution, and that is what we're going to do. So I'm going to use K for keep, and I'm going to say let K be the random variable that represents the number of fish kept. Great. Or the number of fish that can be kept, maybe. Then K is distributed binomially with 15 trials, because we caught 15 fish, and a probability of, well, that's what we worked out over here. Each fish has a 92.29% chance of being kept once caught. We caught 15 fish, so each of these fish had a 92.9% chance of being kept. So that becomes my binomial distribution. Then the probability we're looking for is K is greater than or equal to what? Might want to pause the video and write down what you think it is or think about it. Well, if I am going to throw back at most one fish, that means hopefully I can keep all 15, or maybe I've kept 14 and then only thrown one back. So as long as K is greater than or equal to 14, then I'm good to go. So I want to work out the probability of K greater than or equal to 14. So on my calculator, I'm going to go menu, probability, distributions, and then binomial CDF. Remember, PDF is used for a single probability. CDF is used for multiple. And I'm going to say the number of trials is 15 in total. Probability of success is 0.9229. The lower bound is 14 because it needs to be greater than or equal to 14. If it was just greater than 14, I'd make that 15. And then the upper bound is the same as the number of trials, 15. Press OK, and I get 0.676. Okay, so what I'm going to write down is binomial CDF 15, 0.9299 14 15. Now remember, in a test or an exam, in the test, yes, but in the end of your exam, you don't, strictly speaking, have to write that line down, but it could be useful. But if you're pushed for time, you don't have to write it down. But in our bookwork and in our tests, we're going to write that line down so that your teacher can see if you're making any mistakes. E.g., maybe you wrote binom PDF instead of CDF. Okay, so anyway, I've got binomial CDF And then we've got the answer, which is 0.6762, like so. And I might just put a concluding statement, i.e. 67.62% chance. There we go. So I've got roughly 2/3 of a chance that I'll be able to keep all or at least 14 of my fish. Now, I just wanted to just conclude with a couple of things. Number one, I hope you can see that both normal and continuous distributions, normal and binomial distributions were utilized in the one question effectively. They were both related things. That my normal distribution gave me the probability, which I then utilized in my binomial distribution. It was binomial. The binomial distribution is a discrete random variable. So K is a discrete random variable. And that makes sense because the number of fish I'm catching is countable. 1, 2, 3, 4, 5, up to 15. And this was a continuous random variable because the length of the fish could be any old length. So, they can work together, but you've just got to make sure that you're keeping track of what each of the random variables is describing. And in terms of this particular binomial distribution problem, I could have made it a bit different if I wanted to. I could have, instead of modeling the number of fish kept, I could have modeled it as the number of fish thrown back or released, in which case I would have used 1 minus this probability, so it's like 0.08 basically, and then I could have worked out the probability of 0 or 1. There's no great reason to have done it the other way, other than that's maybe how you might have decided to model it, but it certainly would have worked exactly the same way if you had. So it's always about making choices as to what the best way of modeling it is. Okay, as I said in the previous video, I just want to reinforce here before I sign off, there are so many different kinds of problems that you can be asked. We'll have a quick look at the textbook if it just decides to show up nice and easily. So this is exercise 16D, and there's so many different questions. Like this one, for example, just utilizes the normal distribution, the skill sets that we use in normal distributions. Question 2 is just normal distributions as well, but asks you to consider what the tallest 10% might mean, what the shortest 20% might mean. If I look at question 4 here, we've got between two values, just another normal distribution. Question 5, really quite short, but it's asking you to find the mean and standard deviation of this distribution. So that uses that different skill set that we looked at not so long ago. And then say if we look at question 7 here, you're trying to find some probabilities. And then you've got if 2 males are selected at random, suppose 10 males are selected at random. So we've got some binomial distribution work happening here as well. So it's all a matter of doing as much practice as you can so that you can get a bit more fluent in solving these kinds of problems. So good luck, practice as many as you can, and shout out for help as often as you need.